As you can see here, just a few commands will enable a VPN using these L3VPNs with internal BGP. Obviously, we have to turn on the address family on the BGP. And this will create a new table, bgp.l3vpn.0. And then here we create the instance. We're going to have an instance type VRF. We'll start by giving it a globally unique loopback, one per VRF. And then we're going to be creating the instance, set routing instances. We're going to make it instance type VRF, put the loopback in, put the external interface in. Then this CE is now part of this VRF. It doesn't know, it thinks it's just running ordinary routing protocols. And obviously, as they come into this interface, the routes locally get placed into a new table, c1.inet. Let's have a little look at this route distinguisher. In order to allow for overlapping IP routing in the VPNs, and really that's what part of what it's all about, is so that you can have two different companies with the same routing IP range, maybe 172.30, something like this, but they can be distinguished. And so what we're going to do is we're going to put a route distinguisher on the route, and it's going to keep them separate in the table. So if you were to look into the BGP L3VPN table, you would find that all of the routes have different route distinguishers so that you can see, blue VLAN from red VLAN, customer 1 from customer 2, etc. There's two ways to do those route distinguishers. You can actually set the route distinguisher here inside the instance, or you could set route distinguisher ID globally, and the router will assign route distinguishers for each of your VPNs. The main point about the route distinguisher is uniqueness. So you could have the same route distinguisher on both ends of the VPN, but you don't have to. And the reason is the route target. The route target is a completely different mechanism that we're going to use, again it's a community, in order to place routes from our local box here into the VPN and out of it. And because of that, the route distinguishers can actually be different from both ends of a VPN. In fact, it's an advantage if they are, because it allows us to see which PE has created the particular route. So route distinguishers, as a ballpark measure, by setting them to the internal loopback, the global internal loopback of the PE device, it's going to help. Okay, so as we said, two ways to do it: set it globally or set it locally. They don't have to be the same. Better to do it by PE. So what's the route target? Well, the route target is another community that decides what goes into and out of this global BGP L3VPN table. Here we can see in orange one way to do it. We are going to VRF import and VRF export in and out of that table. So you see them here, VRF import and export. Obviously you'd need a policy, and the policy would be, for example, take the direct routes, take the BGP routes, mark them with the target, and off they go. So these import and exports are using the target, but it's setting them in a manual fashion. Okay, so the simpler way to do that, but less featured, is to just place the target into the interface here. So this is an alternative. You can see I've put OR here. So with the target here, this is going to automatically take your routes from your VRF, push them into the L3VPN table, mark the community on them, and then automatically search the BGP L3VPN table for this target community and re-import them back. So it really sets it all up automatically, this single command here. It's going to take the route, push them into BGP L3VPN, mark them with the community, be on the watch out. If a route comes in with that target, it will pull it back. And that works well. until we come to do hub and spoke layer 3 VPNs. And at that point, it's a more complex design, and we need to be able to control what goes in and what comes out. And that's where these orange commands here come in. We're going to have an import policy and an export policy. And inside that policy, we're going to select the protocol, and then we're going to set the target.